Okay, hey, welcome back, class. Now that we've had practice making ionic and covalent bonds, we can get more into illustrating how these molecules orient themselves. In particular, we're going to see how to illustrate covalent bonds using Lewis dot structures. So, let's state our objective so that we can get into our material. What I want you to get from this video is that you need to be able to illustrate how covalent bonds orient themselves using Lewis dot structures. In saying that, let's dive in. In Lewis dot structures, each element is represented by a chemical symbol. So, for example, if I have carbon tetrafluoride, we know the chemical formula is CF4. That means we have one carbon atom and 4 fluorine atoms. This means that our Lewis dot structure is going to have 1 C and 4 Fs to account for each of the elements present within this compound. For each of these individual elements, we must account for the total number of valence electrons each element can have. A quick way to remember how many valence electrons each element has is that you can start from the left on the periodic table and count the vertical columns over. Make sure you skip your transition metals, but you can count on over. And that's going to give you how many valence electrons are in each column. Once you get to the column with the element that you're looking for, you must account for that specific number of valence electrons in your diagram. So carbon has 4 valence electrons that I'm going to represent by putting 4 dots around carbon. Notice that I put a dot on each side of a carbon atom. This is because of the octet rule. Before I can start doubling up my electron pairs, I must first have at least 4 valence electrons, 4 lone valence electrons. After that 4, then I can start pairing them up. I usually do this, my personal preference is I start on one side of the atom and then I work my way around for each valence electron I have. Our compound has 4 fluorine atoms, so we're going to account for the electrons of each of these atoms. Fluorine has 7 valence electrons if we count over, so I'm going to place 7 dots around fluorine in this order. Notice that leaves 1 dot for each fluorine atom that is not paired up. We're going to use this dot in a second. In covalent bonds, valence electrons are shared in order to create a bond. A covalent bond occurs when one or more electrons are shared from each element. We can represent a covalent bond or sharing of 2 electrons with a straight line. Now all we have to do is connect our lone pairs together to form our Lewis dot structure like this. So here's an interesting question that you may or may not be asking. How do we know which lone pairs go with which atom? Well, the answer is simpler than you may think. All you have to do is memorize this list. C, S, I, N, P, S, O. These are going to be the most commonly used central atoms of your Lewis dot structure, so everything's going to revolve around those. Those are going to be the middle portion. If you have multiple elements that are from this list, you just go in order in which they occur. This is why we have carbon as our central atom and fluorines attached to the carbon as opposed to any other way we could have done this. As we learned in our covalent bond lecture, we can have single, double, and triple bonds. This occurs when multiple pairs of electrons are shared between elements. Let's take a look at cyanide, whose chemical formula is Cn. Carbon has 4 valence electrons and nitrogen has 5 valence electrons, and they orient themselves this way. We know that carbon is our central atom because it comes first in our list. Nitrogen has 3 unpaired electrons though, and those electrons must pair up in order to make this compound stable. So our carbon must share 3 of its electrons with nitrogen and vice versa. This is going to show a triple bond and it is represented by 3 lines. I'm going to end this lecture video with a little bit more terminology that you need to know. Looking at our cyanide molecule, the pair of electrons that are together on the nitrogen atom are called lone pairs. These are non-bonding paired electrons. Electrons involved within a bond are considered bonding pair electrons. These bonds are named sigma and pi bonds. Your sigma bond is your first initial bond, or your single bond, while your pi bond are your double and triple bond, your other 2 bonds that come after your single bond. You just need to know this terminology and take it at face value. Don't get too bogged down by it. And saying that, keep up the good work in class. That's all I got today, and see you next time.